it has been changed into some numbers here. Following, what will be happen with the pixel value originally is 2. It has been changed to something. Okay, so all this thing is coming from here lah. 1.33, 3.08, and also etc. It's good to take note that the transformation function is the one that give us what will be the input and what will be the output. So the transformation function will take the decimal number as precise as possible. If the transformation function did not take the original value, but we take the integer value, then 这个世界就要大乱了。Because small changes, small tiny mighty changes will be having a huge impact on the following pixel value. Okay, coming back here. From 0 to 7, all this thing is my pixel value, or we call it as an intensity. Remember, we use the intensity and also pixel value interchangeably because they are referring to how intense of the color. If the image is grayscale, that means there is only one color channel. If the image is black and white, it's also one color channel. But if the image is color, by using RGB or in OpenCV is BGR, there are 3 color channels. Other than BGR, RGB, what are the color space that is available? How do we define colors? Leave or blue? BGR or RGB? Other than this? CYMK, very good. Lagi? Practical 3, color detection. We did not use BGR, we did not use RGB, we use, very good, HSV. What is the beauty of using HSV in color detection? Value. Why? What is the reason for me to convert the original image, original BGR to HSV? Because easy to find the intensity, as in BGR and RGB, they are 3 color channel. How do I decide which value to go for G, B, and also R the moment when I wish to define the green color, for example? HSV, very good, 0 to 360. It is a round circle. If I put it at 0, it's actually 360.
practical 我还没上。
因为敌人你等的。
Okay, so from the intensity or the pixel values here, which value having the corresponding bar? So I'm going to look at the integer after we round up. So 1, 3, 5, 6, 7. 1, 3, 5, 6, 7. The rest, no more. Yeah, continue. what will be the probability for the image where the pixel having the pixel value 1? So I'm looking back at the transformation function, because transformation function is something like a processing function where we take the value, we get the output. So I wish to know that how many pixel they are using pixel value 1. So I come in and check. 1 is previously 0.19. 0.19.
没聊了。两把进来。
早上还有一模。
3. 3 is coming from 1. So let me take a look here.
都没有开始。
3, they are previously 0.21 more. Sorry. Where I am? 3. Okay. 3. 0. Is it this one? 1, 2, 3, 4. 0.16 plus. S1, yeah, sorry, this one, yeah. 3 is coming from 1. So pixel value 1, 0.25. Take it here. 5 is only coming from 1. So it's 2. So 2, 0.21. Mark it here. 6, I have 2. So they are coming from 3 and 4. So I'm going to add 3 and 4. 这一行 0.16 with 0.08. I'll add these two because they are coming from pixel value 3 and pixel value 4. So these two add it in, and I will get this thing. And the last one is coming from 7. So 7 here, 看这边啊 7, 7, 7. Before this, they are what pixel value呢? 5, 6, 7. So 5, 6, 7. 0.06 plus 0.03, 0.02 is 0.09. So 0.09 is here. Question? Yeah. So the past year question answer for this one that we do last week, I'm going to post it in the Google Classroom. You can cross-check your understanding, see whether you know how to draw the equalized histogram.
还是选个图啊？
什么？这是半的考题。
Alright, continue. If I may allow to remind you about what is spatial domain. Spatial domain is referring to we process the pixel value, we process the intensity directly. Another one, if not spatial domain, frequency domain. Frequency domain make use of a thing called coefficient. Yeah. So this chapter we continue with the spatial domain first. All the processing under spatial domain is consists of two. They are either linear or non-linear. When we say, oh, that lecturer is very linear to the student, that means we taking consideration of everybody voices over here. How about non-linear? A non-linear, they are not going to consider, oh, they will just simply take one of it. Example of the non-linear operation between pixel value 1 until 9. 全部有9个 altogether I have 9 pixel value. I have 9 pixel. But I'm going to choose the maximum. The rest I ignore. Okay, so this is called non-linear. Non-linear except for max, I have minimum or maybe median. They are all non-linear. I repeat, I have mean, I have max, I have median. Non-linear, I'm going to multiply with each of the coefficient, or we can call it as a weightage. How I want the Z1 to be appear on the final value. How I wish to make the Z2, which is pixel value here, to be produce the final one. So it seems like this linear operator having 9 pixel value, and each of the intensity, each of the pixel value, I have their corresponding W, which is weight. The concept of weights is in our practical 2, the last activity. We're talking about the image blending. Yeah, we blend the image together. I have the alpha, I have the beta. Continue. 2 common one, correlation and also convolution. We learned this thing in Form 4 mathematics. We're talking about matrix. Number 1, correlation. The output is actually a weighted sum. Weighted sum is referring to the W of W1. And that's why we have W1, W2, Wn until the ends. So some of the operation under correlation, this is the visualization. The image plates lay down these plates. This is my image. Is F. A, B, C, D, E, F. F is the image itself. After we process, we're going to have the filtered filtered image, which is divided by G. So before and also after. An operation is going to go through a process. Last week, I put this thing here, if you can recall. Please, 我写在这边last week, we said it is either a mask or we call it as a filter or we call it as a kernel. These 3 things is the same. That means we're going to make use of this matrix to be visit all of the pixels within the images. This is a continuous iteration process. So from here, I know that my kernel, my mask, my filter, they are 3 times 3. We also talking about the iRobot thing. We also talking about the makeup thing. We also talking about what is the speed. What will be the result when we choose the different sizes. Okay, so when I'm doing my processing, a kernel comes with a thing called anchor point. Conventionally, the anchor point will be at the center. So anchor serves as a location to be placed on top of the pixel value, pixel number 1. So what happens is that later I use the black colors
Angle
to represent the image. I suppose
嗯，他
each
讲
of
的
the
angle
W I have their
ANCSOR
corresponding pixel as defined in the previous slide.
CHOR.
Yeah, W1, W2, etc. But coming to the edges missing. So I take the anchor point and put it in the first pixel of this image. That's right. So I have W1, W2, W3, W4, and etc. But this thing I did not correctly superimpose the overlap on the image of. So what happened is that we're going to do a thing called zero padding. That means we have the image to fit in 0, 0, 0. The entire image is being covered with a 0 pixel. Why 0? Because 0 multiplied with something, I get 0. So I add it in just like I did not add anything. Because I do not want to extend the image, I do not want to make the image become large, I do not want to disturb any distribution. Because it has a 0 padding. 0 padding is also in our okay. Continue. The applications of correlation. Here. Buddy. The first row. Rock zone there. Rock zone 3991. Today, special offer. Okay, correlation. One of the usage is called template matching. Not sure whether just now you're aware, some of just now I explained to our buddies here saying that one of the assignment topic, question number 4 is talking about object counting. So object counting, meaning that my assignment is talking about user upload an image. System asks the user, hey, what is the thing that you want me to count? User, they're going to select one of the things from the image, then do the necessary. This is just an example how you can use other methods. So user upload this image consists of JAVA, and user decide to choose to count this as this one. So when user already select this, the system is going to help the user to find, is there anything any parts of the image consists of this character, and it's going to return to the user. This thing is called template matching. Even though it sounds good, but in reality, it cannot be done. Why? Simple template matching does not work in most practical cases, where the orientation of the object that we want to detect somehow different, which is true. I have this is the table. Whatever thing that I put it onto the table, the camera is going to detect how many objects are there. How can I ask my staff, ask the Bangla, hey, later you come in to put it this thing very nicely here. I suppose AI help us to reduce the work, but we need to put it here nicely. Nicely. Even rotated a little bit, also cannot be. Not possible. So if you are the one to do this, what you will be proposed? System, we ask the system to to find this. Orientation is different. What can we do? Even though user asks us to find this, no worry ma. Behind the scene, I rotate this image another 45 degree. I have 2 images. I rotate 90 degree. I have 3 images. I rotate the I have images. You understand? So, meaning that even though user only give us 1 images, but I can do my data augmentation to generate more images. Okay. Another issue coming up. Looking at this, how about if the object itself appear to be much smaller than what is given by the user? No worry. User give me this thing 3 times 3, example. I resize it, make it larger. So altogether, I can rotate the images, I can do some scaling, I can do increase the brightness, decrease the brightness, increase the contrast, and also etc. Then from 1 image, I will generate another, let's say 20 image. Use that 20 images as a query to search over the images. Then I can do it better. How about if, let's say, user said, no, I want to find exactly the same sizes of the object that I want from the image. So some users say, yes, I want it to be scale invariance. Some users say, I want to be rotated invariance. Some users said, no, I do not want you to do the scaling. I want exactly the same. I want the same orientation. So what should we do? My favorite quotes are, 小孩子才做选择，大人全部都要. What does it mean? Only the small kids, they will choose one. We as adults, we're going to choose all. If user want scaling invariance, they tick, then I do the searching. If user, they want it to be even different brightness, different contrast, I also can calculate, I also can search, then they want to tick that. Give user an option, then we can do that necessary. Some of the ideas, continue. So we have finished with the correlation. Now we proceed with the convolution. The process is exactly the same, but before we apply the filter, kernel, or mask, we need to flip it horizontally and also vertically. Let's say this is my kernel. So I flip it left to right, up to down. Originally 1, 2, 3, 4, 5, 6, 7, 8, 9. It will become 9, 8, 7, 6, 5, 4, 3, 2, 1. Then apply this kernel to my image. Exactly the same. I repeat. Correlation. Multiply directly. 1 to 1, 1 to 1. W1 multiply with x1. W2, x2. Convolution. Before we do the multiplication, we're going to flip it, flip and flip. Remember, flip it and flip it. My notes here. If Wi and J is symmetry, that means no matter how I flip, they are the same. And if it is the same, convolution is equal to correlation. Example. When correlation is the same with correlation. Then after I flip it horizontally, you want to leave it one because everybody is. So this thing flip it there, this thing flip it there. I still will be getting the seat. And I flip it once again vertically upside down the seat. So if I flip it the same, that means my weight, my kernel itself is symmetry. Let us do some exercise. But I have to answer for you.
没有啊，
没有啊，当然。我睡觉，睡，很累。输了你，赢了世界哟。
妈，这可能是头挡着的人。
喂，蒙白拿头在。OK 吗？是这样。
Student at the back, you can see the text there. Or maybe too thin.
Head too big.
Do not refill.
艺术中，艺术中。其他的地球
There is only 3 times 3 kernel. 3 times 3 pixel. Altogether 9. My K is referring to the inner kernel that must be there. When I do correlation, no flip off, so we use the kernel as is. What is being given here? So my correlation is equal to this one or multiply C. On the corresponding things, 3, you get this. My good advice is we write it multiple line so that later easy for our answer checking. See, I have 3 things, 3 lots. Plus put it at the back. Continue 4 times negative 2. Why I want to do this? Because later I can check very clearly. 1, 2, 3, 4, 5, 6, 7, 8, 9. How about this side? Negative 1, 0, 1, and so we skip the calculation, and what will be the answer? Calculation is enough. I hope you don't manage. Okay, what will be the answer?
你还觉得自己很屌的是吧？现在。
完全都，
你要吗？
完全都。
什么？
我要联络，
什么？
没有这么。
如果你不要拿纸出来写，你看它飞在里面。感觉下个礼拜是
读完就 final 了。
没有，因为呢，他感觉今天交不完整，对不对？呀，去。
We are doing this.
给我 AI 是吧？
So the correlation result at 1-1.
不给你做。
Where is my 1-1? 1-1 that means at the middles. Before this, the pixel, right? And is something. Before this is 8. Before is 5. Now is 8. How about the other pixels? I do one. For this one.
没啥。
I take this anchor point. So I will produce zero here.
什么难哦？你在画什么？哦，OK。
So we
这
have
上面
some
那个你刚
out
有
of bounding of what should I add?
0
So ready, huh?
加0。
So for this, I will have
嗯，什么？你看看，
-1,
嗯，
0. Or maybe
应该是这个意思。
we follow the way of writing just now. This time we put 1 here. Because we have the 0 padding. Sorry. 0.
0 会讲看得懂吗？其实你应该看得懂。
我看到写字蓝色的，
不知道，我写错字，我是看得懂的。你知道就好了，老师。你干嘛？减1加。
第一行蓝色是3个0。
啊，诶，刚刚都讲了吗？如果它外面框的话，它不是全部0了啊？
它有出去没？
现在不出哦。
上面3个是3个0的。
诶，它这个下面那个 I 这个是这个新的框哎，所以它就在这里。现在全部塞进去。
This area is my image. So I have 1, 2, 3. I have 1, 2, 4, 5. That's it. 1, outside, zero padding, zero padding, zero padding, zero
对不对？型号？
padding. Answer?
我没有讲错哦。
5, 9.
干嘛？
Your 9, put it there. rest. We ask our
那个
right.
你一个都要做多久？然后你要把这个手移过去，移过去，移过去。
We will do 4 more.
4 more，我是点点点的哦。
My whiteboard 啦 super big 啊。
好像可以叫人家去哦。闲的。
我这样子 record 了是
19。
The filter. Let's say today, I tell you that this filter is for me to get edges, or maybe I tell you that this filter is meant for us to apply a filter name called London. So certain filter they highlight on certain colors. Let's say this kernel is called like Morandi color. So Morandi colors tune down all of the colors intensity, reduce a little bit. Certain kernel they help me to beautify my face. I do not have any pimples there. When I apply a filter called 小清新, they highlight the green color, brown color, things like that. So when we apply this kernel to the image, I will produce something else. I will produce something else. Not yet finished. You take a look. A. If you notice, I put a dotted red line there. This is for you to check your answer. Because when I move my kernel to A over there. A is the middle ones. This one. All of the value on top, they are 0, 0, 0. This is the second way on how we double check our answer. So all of this is 0, I can ignore. But you need to put it there so that I can really check. 1, 2, 3. Where is my 1, 2, 3? 1, 2, 3. 1, 2, 3. 4, 5, 6. 4, 5, 6. The rest 0, 0, 0. A is correct. B is on the corner. Corner is -9. 你看那边-9. You see? So when I encounter corner, 上面的 on top, these 3 pixels is 0. On the other side, they are all 0, 0, 0. So I will just need to focus on this. But don't write only this area. You need to write it all together so that later you can double check your answer. -9, correct. Moving, C is this thing. So all those 3 values outside, they are 0, 0, 0. So student, we appreciate you write something like this because calculation do have marks. Suddenly, where your 2 is coming from? Avoid this. But the concept here is correct. Write this. Because we do have some marks to showcase the whole calculation steps. So it's 20, 20. Last one. This is correct, but you write it like this one. Suppose 2 multiply with -1, I get this. 3 multiply with 0, you put it here, but you put it here. So flip this thing back to the normal so that we can check the answer. Yeah. Okay. Continue. Something we did not do, but you need to understand. If you did not normalize, you did not control the overflow, marks will be deducted. Whatever thing that we calculate here is actually pixel value. I repeat, pixel value ada ke negative value?
你只是需要
Tak ada.
这两个乘这两个。
So all of the negative things we need to turn it into 0.
这样算到24。
因为它算你
干嘛？24也不对啊。
Why 0? Because negative sign is overflow.
Yes.
Negative 20. Negative 0. Because it is overflow.
妈，这个人的头啊，
下来一点点头，
After normalize,
砍掉。
I will get
左头左三，无用之人的脑就砍掉。不能有那个地方，我就大过9可以。
没错。
没错。
Any question before we proceed?
Thank you, sir. And the class, okay?
You're going to ask me another question one. Less than negative, I put it. Less than 0, I put it 0. How about something more than that? Yeah. If you calculate, you get more than 255. That means something wrong already, So also again, we kept it at 255 because overflow. I repeat, if the thing is more than 255, I get. How about if the image they are not 255? Can we have more? Yes. If the question mentioned like this is a 20-bit image. 2 to the power of 20. So after calculation, if it is more than this value, then we're going to cap it. On 2 to the power of 20. If more than this value, I need to cap it at 1048575 because this is the maximum number available. Like buddy, you have question? Yes, you show me this. Can understand? If let's say I say this image is 8-bit. If it is 8-bit, 2 to the power of 8 is 256. But my pixel value starts from 0 to 555. So anything more than 255, we get it at 255. What to show it? What if the image is 2 to the power of 20? This is the total number total number of pixel value, but we start from 0. So it becomes. So the calculation, when it is over this one, we're going to take this. Moving forward, how about
这才2。
convolution?
这样
We're going to click, click, and click, click.
是 OK。
哇，还好手在那边，
So from here, I will become something like this.
你的脚打到桌子。
How about the
不要动啊
convolution result at 1, 1 here? The answer is negative. Negative eight, no? Less than 0. Yes, it's back. Yeah, less than 0, 0. More than the pixel value allowed, we keep it at the maximum. Normal cases, the question won't tricky like that. If the question did not mention that is the normal cases of this 2.5. I suggest you go back and do this thing. Calculate all together, and then you're going to see what it comes. Let us proceed. So what is the difference between correlation and convolution? What makes convolution so special? Like the same kernel, but I flip it and flip it again. In terms of the kernel flipping, correlation, we do not flip it. Convolution, yes, we need to flip it. Oh, sorry, by the way. If we do all these things in OpenCV, they help us to control the overflows already. We do not need to do the less than 0, I make it 0. If more than that, I control that thing. OpenCV, they help us to do the necessary. Mathematical operation, correlation, help us to calculate the similarity. And that is why we can use template matching. Convolution applies the weight sum with flipped kernel. Primary use case, template matching. Convolution, we do it for filtering, edge detection, image smoothing. Result interpretation, if the image having very high similarity, very high correlation, that means they are having the same. Back to the story, the aeroplane story. If I calculate, oh, that thing and that thing, they are the same, they're having a very high correlation, they are highly similar. In OpenCV, I think I have 6 or 7 ways for me to define how similar that they are. They are all using correlation, but they are correlation coefficient, they are square differences, correlation, and also etc. Modify the pixel value based on the neighborhood. Template matching, logo, eyes. I wish they did the eyes. Convolution is good for Sobel. Sobel is the edge detector. Gaussian, Laplacian filter. Application, face detection, QR code localization, noise removal, sharpening, and also edge enhancement. What is the difference between Gaussian and Laplacian? What is Laplacian? We're going to explore after this. Let us take a 5-minute break. Then we continue. Yes, the filters here, The one simple example is you open your mobile phone, you go to the image editor, down there there's a thing called FX. The median filtering for noise reduction. And let's say, we look at one examples. Let's say we wish to calculate the pixel value of this image at this particularly location, 105. So I take a kernel 3 times 3, and that is the value. Sort the thing from the small to the large one, get the median value will do. So I get 115, the result of this particular location will be turned into 115 after noise removal using median filter. Let us calculate the pixel value for 0, 0. So I put my anchor points here, take 3 times 3. So it is median filter tak ada kernel. We need to understand that our median filter is they are all one. So taking 3 times 3, correct? Since this is towards the boundary edges, so I add in so for these cases, super easy. I have 0, 80, 90, 255. What will be the middle value? Very good. 80 plus 90 divided by 2. 85. So this thing will be changed into 85. Let us do another one. This round, you do this. I click all. Let us calculate the pixel value after applying median filtering using 5 times 5 kernel. So 5 times 5. This is my anchor. This is the center. 5 times 5. Is that in the middle?
今天要去哪里吃？要去哪里吃？说你没有主见的。
会被游泳池。
去那边去吃鸭饭。
没有，等下在哪里上课？
落地啦，不 B 啊 ，boy。
有没有吗？
你跳厕所。
不要给你吃。去游泳池吃。
你去那边应该懂差不多，而不是 spaghetti 就是那个再加一个菜。你在踢球不能吃这样多。
你几点踢哦
？after 2点了。
还有很久哎，现在10点。
对啊，等下10点吃饱，我2点根本没有吃啊。
2点就饿了。
可能呢，等下2点吃了我就不踢了，怕我会吐。看到红饭也是吐，对不对？红饭哦。哇！
坚守就是必胜的一点。
对，坚守必胜。很有素质，你看这眼。
大家好。
1-4-0-2的打。 没有玩。
遇到这样的，现在如果给你，你现在哪里？
我，你顶个几个
啊？
那我就来这里。
是吧？
我都不能讲。
现在顶这边啊，哦，你顶这边哦。
哎，哎，我发现那真的。
我不需要我反应，我一反应就那时候就可以。
在质疑我情况。
对，好，这样我哇，等一下，我记得
大哥可是花50块有票的人，打水漂啊！
原来几粒专业学校，
那一只哦50块，
一件情况
你为学校的建设贡献了一部分。
公对奖，应该是那个。
我放对角，我放这里，哇，放这里。
因为公就是对奖。
不要睡觉，不要踢啊！可以放天地飞机。你可以穿好了，不是我的。哎，不厚道了，
我看到了。放对角，
对角去打。
这里。
想去大操场踢，虽然最黑暗。OK 吗？哦。What the fuck？
怎么要画那个 matrix 出来？这 list 出来吗？
你问我不知道，你问我也不知。没办法，看到对角有周末日夜啊。
天不是天空壁是吗？
安全吗？
是吧？
哪里找105买？
那你在105？
他抄错了。
因为他看这上面那个105，他不是拿115。
怎么还要画那个115？
那你115？
他画那格子在115。
有没？
黑色那个。
没有，黑色那个只是画下来了了，讲是新的。可是嘞，怎么他还拿回旧的，我就不知道。操你妹啊！你不是狂电 WiFi 吗？3个。
然后对角，它就基本上。
你为什么偏帮这个？那些去勇士吃啊！
要执着于防守，没听话跑。
Okay, take a look.
不能会遇到他，
I
他就要
extract
去
all of
有。
the pixel value there
Okay.
with the zero padding. So altogether, I should have 25 pixels. Sort the thing from the smallest to the largest. So I wish to find the middle value. The median value for 25 numbers is on the 30. 9, 10, 11, 12, 13. So after apply median filtering, this pixel this 255 will turn into 95. Again, understanding checking. Median filtering is linear or non-linear? Non-linear. Because I only take one value. The rest I don't care what. I did not apply any weight on each of the value. I just simply sort and take only one. So this is our median filtering. Looking at the median filtering, what is the use case of non-median filtering? It is super good for the images which is suffering from suffering from salt and paper. What is salt and paper? Salt, garam is white colors. Paper, a black paper. So if the image, they have some random occurrence of black and also white pixel, that image is suffering from salt and paper noise. For us to do this, we can use median filtering. Why? Because when I apply median filtering, I will never ever forever to choose 0, which is black paper. I will never choose 255, which is my salt. Because median filter always choose at the median result. And the noise of salt and paper is either 0 or 255. So when I sort this thing, I will never choose 0, I will never choose 255. I will choose some value in between. I feel this is so amazing when I learn image processing. I even question the lecturer, can man. But when I do in the practical, I do in last time I do not use Python, I use MATLAB. So when I try this, see, this is the noise image. Original image, the image that we add in salt and paper. Using average, I'm trying to remove the white spots, the black spots. No good. Median filtering, I almost recover the image into this thing. Right? So this is the use case of median filtering. Okay, I stop somewhere here, and we're going to continue next week. See you.